All right, welcome to 12.9. Solve quadratic equations by completing the square. Yes, we have to remember how to complete the square. So complete the square on both of these. For those who forgot, you take b divided by 2 and square it. So b is negative 12. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. Right? When you're making a perfect square, you are making a quadratic equation that has the same two factors. In fact, in this one, you would write x minus 6 squared. That checks it out, but 36 is what the question mark is. So to complete the next square, it's b divided by 2 squared. So b is 18. 18 divided by 2 is 9, and 9 squared is 81. Let's make sure that's right, though. X squared plus 18x plus 81 makes a perfect square trinomial because it has the same two factors, x plus 9. And you could write those factors as x plus 9 squared. So we're going to find a third way to solve quadratic equations today. The fastest way to solve any quadratic equation, factor it. Sometimes, though, you cannot factor it because the roots or solutions are irrational. So then you're using quadratic formula. But there is a third way called completing the square. Do you need a third way? No. But it turns out that the person who figured out quadratic formula, the way they figured it out was using completing the square. And so you need to know that. So let's just practice completing the square a couple of more times. So we're going to solve this quadratic equation by completing the square. We're going to do the first two steps on this screen, and then we'll finish on the next one. We'll do the same two problems twice. It turns out that you need that number to be the number that completes a square. So the wrong number is there. We have to get rid of it. So how do we always get rid of a positive 3 in an equation? We subtract it from both sides. So we're going x squared minus 8x. We're going to leave a space and then write that equals negative 3. We're going to fill that space with the completed square. This is the same one as the last screen. Negative 8 divided by 2 is negative 4. Negative 4 squared, 16. But remember, you have to add 16 to both sides. And forgetting to add the 16 over there is the single most common mistake with this. So look what we have now. We have x squared minus 8x plus 16 equals 13. We're going to stop right there, and then we'll do the next step on the following screen. Same thing here. We have to get rid of that minus 16. So what do? We add 16 to both sides. We leave a space for completing the square. This is the same one as the last screen. It's 6 divided by 2 is 3. 3 squared is 9. We're adding 9 to both sides. We get x squared plus 6x plus 9 equals 25. We're going to finish that one on the next screen. So let's start again. There's the one with plus 3. We're going to subtract 3 from both sides. X squared minus 8x equals negative 3. Fill in the space with the completed square. It was right. It was negative 4 squared positive 16. We get x squared minus 8x plus 16 equals 13. Now here is the magic. That's a perfect square, like 49 and 64, right? You can take the square root of it. But first, let's factor it. The factors of that, right, are x minus 4 and x minus 4, or x minus 4 squared. and that equals 13. So since it's a perfect square, we can take the square root of it. And we're going to take the positive and negative square root of both sides, but you don't have to write it twice. We'll just write it on the right side. Well, right, if you take the square of x squared, we said that equals x, right? As long as we assume x is a positive number. So those cancel out, and we get x minus 4 on that side. On the other side, we get the positive and negative square root of 13. Well, look, we're almost at an answer, because all we need is x by itself to get an answer for x. So what do? We add 4 to both sides. And the solutions to this quadratic equation occur at 4 plus the square root of 13 and 4 minus the square root of 13. Let's try the next one. It's the same as the last screen. We have to get rid of the minus 16 on both sides. We leave a space so we can complete the square. 6 divided by 2 is 3. 3 squared is 9. So we're adding 9 to both sides. So we have x squared plus 6x plus 9 equals 25. The factors of that are x plus 3 and x plus 3, or x plus 3 squared. We're forcing that step to happen by completing the square. Now, we're taking the square root, positive and negative square root of both sides. But look at this. This time, we know the square root. So it's positive 5 and negative 5. We're almost at the answer again. Subtract 3 from both sides. And so we have x equals negative 3 plus 5 and negative 3 minus 5, also known as the numbers 2 and negative 8. Well, that didn't come out irrational. That's right, because this works on rational or irrational ones. This one up here was in fact factorable. What were the factors, right? X minus 2 and x plus 8. Boy, that would have been way faster. That's why we hardly ever use this method, all right? When it's factorable, you want to factor it, but you have to know this method because it's the way the quadratic formula was figured out. So let's practice. Get rid of the negative 39. Now complete your square. So that's 25. I almost put 100. 10 divided by 2 is 5. 5 squared is 25. Factors of that are x plus 5 and x plus 5. 39 plus 25, I suspect, makes 64. Take the square root of both sides, positive and negative square roots. So we have x plus 5 equals positive 8 and negative 8. Subtract 5 from both sides. X equals negative 5 plus 8 and negative 5 minus 8, also known as 3 and negative 13. Yeah, that one again was factorable. Completing the square not only isn't needed because there's already 2 other good methods, but it only works when the coefficient of x squared is 1. But you can force that to happen if there is a common factor. So here, there's a common factor of 2. We're going to remove it. Whoops, you know what? So we can divide by 2 both sides. Took me a second to remember what you can do here. X squared plus 10x minus 12 equals 0. Notice I divided both sides by 2, and that 2 just goes away. We're going to add 12 to both sides to get rid of the 12. We're going to complete the square. is 25 again. The factors are x plus 5, and x plus 5 equals 37, so that's not a perfect square. Take the square root of both sides, positive and negative. So we get x plus 5 equals positive and negative the square root of 37. Subtract 5 from both sides. X equals negative 5 plus or minus the square root of 37. And that's the way it comes out more often than not. This one, the constant is already missing. So all you have to do is rewrite it with a space. B is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So we're adding 9 to both sides. The factors there are x minus 3 and x minus 3. Negative 2 plus 9 is 7. Square root of both sides, positive and negative. X, so we get x minus 3 equals positive and negative square roots of 7. Add 3 to both sides. X equals 3 plus the square root of 7 and 3 minus the square root of 7. Today's Easter egg looks like that. Maybe you recognize that guy, but it's in the Schoology videos. It's not, didn't play here, so I had to include it elsewhere.